Alrighty, so today what we're going to do is we're going to talk about linear programming and optimization. So if you notice there on the sheet I've given you, the first statement, companies hope to maximize profits and or minimize their costs. Now what ends up happening is usually when companies have business plans, they have to kind of have a projection as to how long it's going to take them a point to break even or how long it's going to take them before they start making a profit. And so anyway, so companies actually look at something like this. Now granted, the scale they look at it is a lot larger than the scale we're going to look at it. But anyway, we're going to go ahead and do some linear programming today. Linear programming is a method for finding maximum or minimum values of a function over a given system of inequalities. And so when we go through this process, we have something known as the feasible region. Okay, the feasible region is the vertices of the solution set. So basically, when I think about the feasible region, that's where everything intersects. And then that's kind of like the boundaries or the corners. And so on the next slide, you're going to notice there are two feasible regions. The first one we call is a bounded feasible region because if you notice, imagine that the outside lines would be a fence. If that was all fenced in, you wouldn't be able to have anything escape or whatever. Everything would be contained in that area. And so notice you have three vertices there. Your vertices are the points or the corners at which they intersect. And so here you go. There would be your vertices. And so we call that a bounded feasible region. If you've got a bounded feasible region, you have both a max and a minimum. Okay. Then we have an unbounded feasible region. Now if you notice this one, it's unbounded because everything's not fenced in. Everything is not contained. And so if you notice here, here are my vertices. I only have two of them. Now in an unbounded region, you only have a max or a min. So you have one or the other, but you will not have both. So let's go ahead and look. We're not going to go through this entire thing today. We're going to go through the first three. So if you want to start with number one, it says graph the system of inequalities. Name the coordinates of the vertices of the feasible region. Find the max and the minimum values of the function for this region. So now if you notice there's four lines. The one that you graph are the first three. That bottom one that says f of xy, you're going to hold off on that one. So you will not do anything with this equation until later. So we need to graph the first three. So very first, pick out a light color. Okay. So pick out a lighter color. And we're going to start by graphing 3 is less than or equal to y is less than or equal to 6. Okay. So 3 is less than or equal to y is less than or equal to 6. Okay. There we go. So I'm going to start by drawing a y equals line at 3. So there's going to be your first line because that's at y equals 3. Your second line will be at y equals 6. And from that inequality, they tell you that y is between those values. So you're going to go ahead and shade in between .
Oh, you don't want two different colors?
Just that one. So that first equation can be modeled by the pink.
Do you have a sharpener?
I went through and sharpened up somewhere. Okay, so go ahead and shade that in. And then we'll go ahead and get started with the next one. So get that one shaded in. Okay, so now the second equation. What can you tell me about the second equation?
Oh, the y-intercept's 12.
The y-intercept is 12, okay, so 6, 7, 8, 9, 10, 11, 12. What else can you tell me?
The slope is 3.
Slope is 3. So slope is 3 means you're going to go up and over. The problem is we don't have any room.
You go
So
down
it's-
3
yep.
over.
Instead of going up 3 and over 1, we're going to go down 3 and to the left 1.
Okay.
Okay? And so then now all we need to do is connect those dots, and then we're going to figure out what side of the line do we shade.
Okay.
Okay, so now we need to plug in a point.
0.
Let's plug in the point 0, 0. So you're going to plug in 0 for y and 0 for x.
0 is
So you end up getting 0 is less than 12. Is that true? So you're going to shade on what side? Yep, to the bottom right. So go ahead and shade to the bottom right.
You shade that whole thing.
Yep.
Why do you shade to that side again?
Because when we plugged in 0, 0, we got a true statement. So we're shading on the side with 0, 0. So now we need to graph the third equation. So what can you tell me about the third equation? The y-intercept is 6. The slope is what?
-2 over 1.
So that means I go down 2 over 1. So then I need to go ahead and draw a line.
Down 2 over 1.
Yep. Oh, wrong one. Let's go here to this one. There we go. Now I need to figure out what side am I going to shade. And so I'm going to plug in the point 0, 0. So if you plug the point in 0, 0, you end up getting 0 is less than 6. Is that a true statement?
Yes.
Yes, so we're going to shade on the side with 0, 0 since that statement is true. Now what's going to happen is we're looking for the area that's shaded all 3 ways. And if you notice, I'm going to go ahead and make some boundary marks. I notice that this is shaded all 3 ways. A boundary is right here, and a boundary is right here. So what shape is it?
Polygon.
Yep, it's a trapezoid. It is a polygon, but more specific, it's a trapezoid. And so this is the area that's shaded all 3 ways. Now what I need to do is come up with the coordinates for each of those boundary points. So what is one coordinate of one of the boundaries? -3, 3. Good. What is another one?
2, 2.
-2, 6, and you said 0, 3, or 0, 6, sorry. And you said the point, and this one is actually 1.5. It's not quite at 2. This point here is actually 1.5. And so what those 4 points are is our boundary points. So far we've graphed the system, we've named the coordinates of the vertices. The last final task is to find the maximum and minimum values for this region. So all we're going to do now is take -3, 3, and we're going to plug it into this highlighted equation. So I'm going to take 4 times -3 minus 2 times 3 and get an answer. What does that come out to be?
-12 minus 6 is
-18.
-18. So that's the
Now what I'm going to do is I'm going to do the same thing with each of the 3 remaining points. So I'm going to take 4 times -2 minus 2 times 6. And what is that?
-20.
Negative 20. Now I'm going to do the same thing with the 0, 6. 4 times 0 minus 2 times 6.
Negative 12.
Negative 12. Okay, negative 12. And then last but not least, I'm going to take 4 times 1.5 minus 2 times 3. And what is that?
-6. Well, isn't 6 minus, 0.
0. Now, is this a bounded feasible region or an unbounded feasible region?
Bounded.
It's bounded. Everything is contained. And so as a result, the maximum will be the highest value. And what's the highest value going to be?
I think it's 0.
0. So that's our max. Since it's a bounded region, it's also going to have a minimum. What's the minimum going to be? Negative 20. So there you go. That is your answer. So pretty much it's real similar to what you've done in the past. You're just adding about 2 more steps on to the end. Alrighty, so we're going to go ahead and look at the second one. So the second one, same instructions. So I'm going to first of all start with negative 2 is less than or equal to x is less than or equal to 6. Now, this is x. So x means what type of line? Vertical, yep. So I'm going to go ahead and draw a vertical line in at negative 2.
And then
Where else
6.
am I going to draw? 6. And what are you going to shade?
Okay. In the middle.
In the middle. So there you go.
Always shade in the middle.
If it's given in that form, yes.
Let's see.
Now this one's nice because you're going to notice that your next set of equations are what type of lines? Horizontal.
Yeah.
So if you want to go ahead and start graphing those, go ahead.
The second one's horizontal.
The second one is horizontal.
Okay.
So the second ones are located at
1, 5.
1 and 5
Why is that one horizontal?
because it's y.
Oh, okay.
So where are you going to shade those?
My
In the
hori-
middle, that's
my
right.
horizontal and vertical are off.
Okay.
Yeah, we messed up the whole. You know you're off.
So if the arrows were pointing the other direction, we would point on the outside, we would draw on the outsides.
No, there's really, this is about the only way you can write it
Okay.
and make a true statement.
Cool.
That's correct.
Next one, y-intercept's 3.
So now on the very last one, the y-intercept is what?
3.
3. So 1, 2, 3, I'm going to put a dot. What is my slope?
1,
Up 1 over 1. Yep. So I'm going to go ahead and draw a line through there. Okay. Now I need to figure out what side I'm going to shade it on. So I'm going to plug the point in 0, 0. So if I plug 0 in,
You'd shade to
I-
the bottom.
0 is
shade
less
to the
than 3.
bottom. Yep.
So you shade towards the 0?
If it's right,
Yes.
it's true.
If it's a true statement, you will shade in the side with 0, 0.
Okay.
So what type of shape do I have for my region? What type of shape is it? Yes.
Is it a trapezoid?
Okay, so here's one boundary right here.
Oh, there's a triangle. No, there's not. Yeah, there is.
I go all the way over to here, here's another boundary. I go all the way up to here, here's a boundary. I go over to here, here's the other boundary. So there you go. There is your boundary. Now, will it always be trapezoidal in shape? No. It depends on what you're given. Once you get those boundaries in, you need to go ahead and specify the 4 points. So go ahead and write those down. When you get your 4 written down, I want you to compare yours with the ones I have. Now, how I always do mine is I always start at the leftmost part. And so you're always going to notice that I try and get my negatives first, and then I gradually work my way to the right. But you can do it whatever way works for you.
If it's not in the exact same order, is that okay?
Yes.
Oh.
It doesn't have to be in the exact same order as mine. So I'm going to go ahead and start plugging in values. I want you to go ahead and plug in values. Okay, where am I going to plug those in? Yep, so negative 5x plus 2y. So go ahead and plug those in. Identify what you think the max and the min are. See if your answers match up with mine when you've got them done. What did you get the max to be? 12. What did you get the min to be? Negative 28. Good. So do we kind of see what we're going to have to be doing here? So up until this point, we've dealt with bounded regions. We haven't dealt with then unbounded regions. So let's go ahead and look at the next one.
I have a feeling it's
Okay.
gonna be unbounded.
That would be a good guess. Okay, this is the very last one we're going to look at today. Okay. And so what we need to do on that very first one is we need to find what the slope and the y-intercept are.
Oops, -3/2.
Be careful. Oh yeah, that is right. The slope is negative 3/2. That's right. Notice you've got to switch your x's and y's. So slope is negative 3/2.
Be careful.
What's your y-intercept? Be careful, and this will do. What's your y-intercept going to be here? Negative 12 divided by what? 2, which is negative 6.
It's 2.
Because remember, we should write it as 3x plus 2y.
So, like,
Really, we should, if it's going to be written in standard form, it should be 3x plus 2y is greater than or equal to negative 12.
So that's when you divide by.
Yep.
That's the one.
Yep, so our y-intercept is at negative 6, which should be right down here. And a slope of negative 3/2. Negative 3/2 means you go down 1 and over. In this case, I'm going to go up 1 or up 3 and to the left. Let's go ahead and draw our line in. And now I need to figure out where do I shade. Cool. Where am I going to shade?
The second one.
Where am I going to shade this line?
I don't know, towards the 0?
Why?
Because it's a true statement.
So what's the true statement?
I don't know. 0 is
Yep.
less than
0 is greater than what? When you plug 0, 0 in, you get 0 to be greater than what number?
3.
If I plug 0 in here, 0 in here, you get what on the
12,
left side?
negative 12.
You get
Right.
0 is greater than negative 12, and that's true. 0 is bigger than negative 12, so that's why you're going to shade here.
Okay.
Let's look at the next one. What's your what's your y-intercept of your second line? 12, yep. What's the slope? 3. So which way are you going to go since I can't go up 3 over 1? Down 3 to the left 1. So go ahead and draw your line in. Now let's figure out what side. Shade to the what? The right, yep. So we're gonna shade to the right, folks. The very last one. Okay, y-intercept of negative 6, which is down here,
Well, you go up 3 over 1.
up 3 over 1. Draw our line in. Which way do I shade? To the left, good. So now we're looking for places where all 3 are shaded.
Right there.
So there's 1. Okay. Then up along this line, then up along that line. So there you go. So you can obviously see that this is what type of region?
Unbounded.
Unbounded. So how many vertices do we have? 2. Yep, good. Where are they located at? Yep, so tell me what they are.
Negative 0, negative 6.
0, negative 6 is 1. Where's another one?
Negative 1, 4.
Negative 4, 0. So now what I'm going to do is I'm going to go ahead and plug those values in just like I did in the problem before. So I'm going to plug 0, negative 6 in. And so when I do that, I get 9 times 0 minus 6 times negative 6. What does that give me? 36. Good. Now I'm going to plug in 9 times negative 4 minus 6 times 0. What is this one? Negative 36. Now here's the problem. Okay. If you remember, in an unbounded region, I can only have a max or a min. I cannot have both. So now I need to figure out which one is the max. So do I have a max at 36? So is this a max? Or is this one a min? And so in order to determine which one of those is correct, what I need to do is look in the region itself. And I'm just going to pick a point. Okay, so if I look here, I might pick a point, kind of if I'm thinking about some bigger numbers, because look I need to get to 36 or negative 36, something bigger than that. And so if I look at the y-axis, I could pick the point 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or I could pick the point 0, 10. Because notice, that's still in the region, right? So let's just pick the point 0, 10. When I plug 0, 10 in, what do you get?
I don't,
9 times 0 minus 6 times 10. Negative 68. So that value,
wait, why'd you use 68? How'd you get
or
68?
sorry, negative 60. I was thinking negative 60. For some reason I wrote negative 68. There you go. So the answer is negative 60. And so in looking at that, which one of the two does it eliminate?
I don't,
Minimum.
The minimum. Why does it eliminate the min?
Because it's higher.
Because it's lower.
Lower.
So this is actually a smaller value, so this could be a minimum. But when you think about it, it's going to keep going on forever and ever. So the only thing this has is a max, because we've proven that one doesn't exist. Now the question is, which number do you plug in? It's trial and error. You just have to keep plugging in a number, or plugging in points, until you get something that eliminates one of the two. But if you notice one of the things we looked for a point that was big, 0, 10. Okay, because we knew we had to get somewhat of a big number. And so that will be the case with yours. Try and pick a bigger point that's going to give you some bigger numbers there. Another good idea is to use one that's on the axis if you can, the x or the y axis, because one of them then is 0. So we're going to continue and finish this handout tomorrow. Okay, if you want to go ahead and get started on your homework, which some of them did, so that you maybe don't have as much to do over break, you can go ahead and get started on page 157, 8 through 16, the evens. Okay, page 157, 8 through 16, the evens.